Welcome back to Mr. Vaughn's classroom, where he makes math so easy, even I can do it.
Before we get started on this video, I'd like to ask you to please hit the subscribe button, give this video a thumbs up, and engage with a comment below. In this video, we're looking at Unit 2 on congruence. This is Lesson 12, Proofs about Quadrilaterals. The learning goal for this lesson is to prove theorems about quadrilaterals and their diagonals. We have 3 learning targets in this lesson. Number 1 says that you can critique a proof about quadrilaterals. Learning target number 2 says that you can prove theorems about quadrilaterals. And learning target number 3 says that you can rewrite a conjecture so it is specific enough to prove. For glossary terms, we're going to start with rectangle. This is a quadrilateral with 4 right angles. And we're going to have rhombus. A rhombus is a quadrilateral with 4 congruent sides. Now that we're done with the introduction, let's get started on the practice problems.
I'm once again asking you to solve this equation, and don't tell me we can't afford to get to the answer.
Practice problem number 1 says that Lynn is using the diagram to prove the statement, if a parallelogram has 1 right angle, it is a rectangle. Given that EFGH is a parallelogram and that angle HEF is right, which reasoning about angles will help her prove that angle FGH is also a right angle? So if she is trying to prove that angle FGH is also a right angle, then FGH would be this angle in the bottom right. So if we read through our choices, A references corresponding angles, B references opposite angles, C references vertical angles, and D references the base angles of an isosceles triangle. Well, if I am talking about the top left corner angle and the bottom right corner angle, then I am referencing opposite angles. So out of these choices, the only one that references opposite angles is choice B. So that means A, C, and D are not the reasonings that would specifically help us prove that angle FGH is also a right angle. I hope that this makes sense to you. I hope you notice that it depends on what we're trying to prove, and that since we're trying to prove this specific angle, and because this specific angle happens to be opposite of the angle that we're given, then we want the statement that talks about opposite angles. But if you do still have any more questions, please feel free to leave a comment below.
You kids have it easy. Back in my day, we didn't have calculators. We had to use our noggins.
Practice problem number 2 says ABDE is an isosceles trapezoid. When we see them say isosceles trapezoid, what they mean is that we have a pair of parallel lines, so AB at the top and ED at the bottom, and then we have one set of congruent sides, so AE and BD. Select all pairs of congruent triangles. So in the first example, we have triangle ABE. So ABE means we have this triangle right up here. And triangle DBE, which is going to be this triangle down here. So we know that we have the congruent sides that were marked. So we have side, and then we know that they share the side BE. So we do have side, side. However, AB is not congruent to ED, so we don't have the other side. And we do not have the angles that are in between the sides. Angle AEB is not congruent to angle DBE. So we only have side, side. That is not enough to have congruent triangles. So now let's try B. Choice B says we have triangle ABD. So that's ABD. We draw the line here. So we're talking about this triangle in blue. And then triangle DAE. So these triangles in blue and green. Well, again, we have the corresponding sides here, or the congruent sides here. They share the line down the middle. So that, again, is two sides. But again, AB is not congruent to ED, so we don't have the third side. And if I'm looking at the angles between, angle EAD is not congruent to angle BDA. So only having two sides is not enough to say that the triangles are congruent. Choice C. Triangle ABE. So A, B, B to E, and then E to A. We have this blue triangle up here. And triangle BAD. This green triangle. Well, first, we know that we have the congruent sides that are marked. So we do have side. Then we know that they share side AB. So that is going to be a second side. And now, if you look on the blue triangle, the angle between angle A here was marked with 2 tick marks. And on the green triangle, the angle between the sides we have, this angle B, was also marked with 2 tick marks. So in fact, the angle between the sides is also congruent. We now have side, angle, side, and that is enough to prove that those two triangles are congruent. Option D, triangle A, E, D is going to be this blue triangle. And triangle B, D, E is going to be this yellow triangle. So in this situation, we have side AE congruent to side BD. So there is one side. We can see that they both share side ED. So this is another side. And we can see that the blue triangle has angle AED that they marked with 1 tick mark. And the yellow triangle has angle BDE that they marked with 1 tick mark. And these angles are the angles between the two sides that we already know are congruent. So again, we do end up with side, angle, side, and because of the side, angle, side triangle congruence theorem, this does prove that the triangles are congruent. And our last choice, E, triangle E, A, B, is this blue triangle. And triangle E, D, B is this yellow triangle. We can see that the blue triangle has side AE, which is congruent on the yellow triangle to side BD. So we do have one side. Then we can see that the two triangles share side BE. So there's another side. But just like A and B, side AB is not congruent to side ED. So we don't have side, 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 which means we would need the angles between the sides. However, AEB is not congruent to DBE. So we do not end up with side, 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 or side, angle, side. So E does not form congruent triangles. I hope it helped using the coloring and the diagramming. I hope that helped make this make sense to you. Remember that in order to prove these triangles congruent, we either needed to end up with side, 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 or we needed to end up with side, angle, side. And the important part is that the angle must be the angle between the two sides. Or we need to have angle, side, angle, where the side is between the two angles. So on C and D, we did end up with side, angle, side. So those two formed congruent triangles. Unfortunately, on A, B, and E, all we ever got was two sides, and that is not enough to have congruent triangles. If you still have any questions about this practice problem, please leave a comment below.
We're going to solve this problem not because it's easy, but because we need to get to Mars.
Practice problem number 3 wants us to match each conjecture on the left with the rephrased statement of proof connected to the diagram on the right. So let's look at A. A says the diagonals of a parallelogram bisect each other. So when we're talking diagonals of a parallelogram, we're talking about EG and HF. Now, if we read through these, number 1 talks about GH congruent to FE. Well, GH is the line along the bottom, and FE is the line along the top. That doesn't have anything to do with the diagonals, so it wouldn't be number 1. Number 2, in parallelogram EFGH, show that GH, the line along the bottom, is congruent to FE, the line along the top. Again, that doesn't have anything to do with the diagonals. Number 3, in quadrilateral EFGH, with EK congruent to, actually, let me just use a line. All right, we're saying that EK is congruent to KG, and FK is congruent to KH. All right, that has to do with our diagonals. But then it says, show EFGH is a parallelogram. Well, A didn't require us to do that, so it wouldn't be number 3. So the only one left is choice 4. In a parallelogram EFGH, show EK, we marked that with 1 tick mark, is congruent to KG, we marked that with 1 tick mark, and FK which I marked with 2 tick marks, is congruent to KH, which I marked with 2 tick marks. Well, if that is true, the line segments with 1 tick mark are congruent to each other, and the line segments with 2 tick marks are congruent to each other, then that does prove the diagonals of a parallelogram bisect each other. So A is going to match number 4. Conjecture B. In a parallelogram, opposite sides are congruent. So now we want to talk about the sides. So number 1 says in quadrilateral EFGH with GH, the line on the bottom, congruent to FE, the line on the top, and EH, the line on the left, congruent to FG, the line on the right, show EFGH is a parallelogram. Well, that last part is not required in B, so it wouldn't be B. But if you look at number 2, in parallelogram EFGH, show GH, the line on the bottom, is congruent to FE, the line on the top, and EH, the line on the left, congruent to FG, the line on the right. That does support B, which says that in a parallelogram, opposite sides are congruent. So B is going to match number 2. Conjecture C. A quadrilateral with opposite sides congruent is a parallelogram. If you look at proof number 1, in a quadrilateral EFGH with GH, the line on the bottom, congruent to FE, the line on the top, and EH, the line on the left, congruent to FG, the line on the right, show EFGH is a parallelogram. That matches with the conjecture a quadrilateral with opposite sides congruent is a parallelogram. So C is going to match number 1. And the last conjecture, D, if the diagonals of a quadrilateral bisect each other, then it is a parallelogram. Well, the only proof we have left is number 3. In quadrilateral EFGH with EK, the top diagonal, congruent to KG, the bottom diagonal, and FK, the upper right diagonal, congruent to KH, the lower left diagonal, show EFGH is a parallelogram. That matches the conjecture D. If the diagonals of a quadrilateral bisect each other, then it is a parallelogram. So D matches number 3. I hope this helps you understand how to match conjectures with statements of proof. You just need to make sure that they are talking about the same things. Are they talking about the diagonals, or are they talking about the opposite parallel lines? And how much is it asking for? Is it only talking about the diagonals or the parallel lines? Or is it also then extending it into a statement about the whole parallelogram? So you just have to read carefully, make sure you match them up correctly. Again, if you have any questions still, please feel free to leave a comment below. So let's review these learning targets real quick, just to make sure you understand everything you need to before you move on to the next lesson. We had 3 learning targets, and the first one says that you can critique a proof about quadrilaterals. So this simply means you can recognize whether it is talking about the sides or the diagonals. Are you saying they're congruent? Are you saying they're bisectors? Are you saying they're parallel? Are you saying they're congruent? You can pick apart a critique or a proof and talk about the different parts and decide whether it is a valid proof or not. You can look for things like, okay, they have 2 sides and an angle, but is it the right angle? Is it the angle between the 2 sides? You can look at a proof that talks about angle, side, angle, and you can critique whether or not it's the side in between the 2 angles. So that's what we mean by you can critique a proof about a quadrilateral. You can look at someone else's proof and pick it apart and decide whether or not their proof is valid based on the rules that you know. Learning target number 2 says that you can prove theorems about quadrilaterals. So this is where it's on you. It's where you know how to use different rules. You know how to prove something based on parallel lines, or you know how to prove something based on side, 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 or side, or angle, side, angle. You know how to talk about alternate interior angles. So that's what we mean on this second learning target, is that you now understand several of these rules and you know how to write out a proof and talk through it step by step so that you are the one actually proving something about a quadrilateral by using those rules. And then learning target number 3 says that you can rewrite a conjecture so it is specific enough to prove. So this would kind of line up with that third practice problem where you know how to write the conjecture so that it can be proven, and it can be proven to the degree that you're talking about. So are you only talking about the diagonals being bisectors, or are you saying that it's proving something about the parallelogram as a whole? Are you only talking about the pairs of parallel sides, or are you then using those parallel sides to prove something about the quadrilateral as a whole? So we're just saying that you need to be able to write them specific enough to prove what you want, but not too specific where it starts proving something you're not even talking about. So I hope that you understand these 3 learning targets. But if you do have any questions, please feel free to leave a comment below and reach out. If you found this video helpful, please give it a thumbs up. If you find this series of videos helpful, then in the bottom left of your screen, you should see another video that YouTube is recommending to you. And in the bottom right of the screen, you should see the subscribe button for the channel. It would really help out if you would subscribe. I look forward to seeing you in the next lesson.